Welcome to the How to Be Moderately Successful podcast. I'm your host, Mike Scott, and I'm also the co-founder and CEO of Nona Digital. This podcast is all about helping you to build better businesses, better FinTech products, and a better version of yourself. We get a lot of messages to thank us and our guests for the content that we're putting out, which I can only assume means you're getting value from the podcast, which is great. But if you'd like to support us, the best thing you can do is give us a rating and a review. You'll be surprised at how much each one actually helps. You'll also be surprised at how difficult it is to do this. It's surprisingly difficult. So we set up a link to make it easier. You can go to ratethispodcast.com/how to be moderately successful. We'll drop this in the show notes too, and thank you in advance. Today's episode is sponsored by ourselves, Nona Digital. Building a FinTech business is difficult, and building the software that enables that business, that scales, and that your users love is very difficult. In today's hyper-competitive environment, getting your software built right really does matter. But you also need to focus on building your business, your team, closing your next deal, and making the impact that you need to make. And this is where Nona can help. With an excellent track record of delivering scalable, intuitive software for FinTech companies around the world, we'll take away some of your stress by making sure that your product is designed and built at the highest standards and by people that really do care. We're small enough so that you're always close to the principles, but big enough to be able to deliver at the highest standards consistently without key person dependency. We've got deep expertise in FinTech and particularly in blockchain application development. And we've also got a proven track record of expanding and evaluating internal tech teams and capabilities for our partners. So if you would like to accelerate your FinTech project with a team of experts, we'd love to hear from you. Head over to nona.digital to book a call directly with one of the principals or follow any of the contacts in the show notes. I've got to plug this. We are actively hiring senior developers and technical leads, and we're offering a very decent bounty for any referrals. So if you know of any senior developers that might be a good fit for Nona, please do get in touch, and there might be a meaningful and tasty reward in it for you. And now onto the show. Today, my guests are Dave, who is no stranger to the show. He is one of my partners at Nona Digital and our CTO. And for his first appearance, we've also got James Smith today, who is our head of engineering at Nona. Welcome, James, and welcome, Dave.
Hello.
Thanks, Mark. Always a pleasure.
Always a pleasure. Right, guys. So today we're going to be talking about probably many things, but the sort of theme is the different approaches that one can take when it comes to building software products. And really what I'm talking about here is we get a lens into the broader industry because we see a lot of startups and a lot of companies. We see well-funded companies, we see not funded companies, we see bootstrapped, we see all kinds. And I often get asked the question, why can't we just build this really fast and cheap and then figure it out later? And this is kind of what we want to dig into today. So we want to talk about sort of going really fast and breaking things versus going at a sustainable pace and doing things properly. And that might not be as simple as it sounds. So let's kick off there maybe just with a simple question. And I'll start with Dave. Dave, talk to me about some of the risks of going really fast, but going really badly. So just like slapping something together that, yes, will sort of be functional, but maybe not. Let's just start there. Talk to me about why that may or may not be a good idea.
Cool. All right. Well, let me start with why it may be a good idea. Sometimes it is a good idea in the circumstance when you know very specifically exactly what you want, and you know that you're not doing it for the long term, and you're perhaps incredibly time constrained, and what you're doing is quite small. And I'll sort of maybe circle back to why that last point is a factor there. I'm just going to go by whether James nods or not, really. It's going to guide me as I talk. So that's why you may want to do something like that. The main reason that you may not want to do it is that essentially, if you're doing stuff in a very non-thorough way, if you're doing it in a quick and dirty way, and I think that's an important qualification. You can do stuff fast and properly as well, and over time that will pay off more. But if you're doing stuff and you're like, look, we're not going to care too much about making sure this is built properly. We're going to just get everything done without thinking it through. We're not going to have automated tests or maybe any kind of test. We're just going to be like, okay, cool, looks good enough, send it. The main problem that you run into is the longer you spend on a project like this, the more maintenance cost and unforeseen problems you're going to have. Because the more you add to it, the more there's going to be cases, and I'm sure anyone who's done dev is probably familiar with this, where you want to add a fairly innocuous feature and you say to your development team, hey, can we not just add login with Google instead? And then they're like, oh, that's going to take 2 months. And you say, why? And they say, well, because we never built it in the kind of clean, open way we should have, now we need to rework a whole ton of stuff to be able to do that. And I guess that's a short answer. The longer you go down that road, the more hidden costs you're going to have. There's quite a cool metaphor around that with technical debt as actual debt, but I think let me say that maybe for another answer.
I remember that from a previous podcast, which I've used many times. James, anything to add on that? I saw lots of nodding. Any color to fill in there on what what Dave has been speaking about?
Yeah, I think what Dave's referring to is the velocity of your team will asymptotically approach zero, as the problem being mostly that you will just break things by adding things. So the cost of adding a new feature is not the cost of adding a new feature. The cost of adding a new feature is doing it in whatever hacky way you've done, changing it in multiple places, and also fixing all the unforeseen and emergent phenomena that have happened because it's not a cleanly factored application. That's
right.
I tend to think of these things in terms of like a lot of things. There's a continuum. All the way at one end, you could just be, okay, I'm going to work as many hours in the day as I can. I'm going to 16 hours, going to go, just going to quick commit, no test, nothing, whatever. It's easy to see how on that end of the spectrum there's problems. It's actually sometimes more interesting to think about where the right line is on the other side of the spectrum, because it's not obvious that the other extreme is good either. Most of us are not writing software for taking us to the moon, controlling a nuclear reactor. So taking that long with that many safety factors around the thing is perhaps not the best thing for our clients either. And that can be where the real problem is. It's always easy to see the symptoms of moving too quickly. It's sometimes more difficult to see to know when you're moving too slowly.
Right, and I think it's a really good point you raised, because I mean, even as I sort of introduced this, it was kind of like, it sounds like the discussion is, well, you shouldn't just go too fast and break things, but it's seldom raised like going too slowly because you're being too thorough. Something you touched on pretty lightly there, James, was writing tests. And I actually had a conversation with somebody today. The audience of this podcast is generally not going to be super technical. So put yourself in the shoes of a founder, probably very smart, probably a subject matter expert, but certainly not technical, maybe has worked on a project or two. Tests are one of the things that a decent software development company should be doing, but it would appear from my experience that very many providers are not doing. What are tests? Why are they necessary? And as a non-technical person, how would you assess whether your software is being tested?
Okay, so we can distinguish here between testing as in just verifying that your software does what you think it to do in some way, right? That could be done manually, which everyone will do, because you're going to use a product and you're going to click through the screens. You're going to test that something actually works as you expect. But when we talk about testing, for the most part, we talk about automated testing, which is writing code that exercises the application code and verifies its correctness. The benefit of this is that you can run that as many times as you like. You can run it with each change. You can run it before you create a new version of your software, before you deploy. And what you'll see is that as you add features to an application, manual testing becomes, I mean, if you can think about it, like the scaling around that of like, okay, now you've got to test every single feature and how it interacts with this feature. To put human time into that can become very problematic. You can see there's some examples we can look at online of the old testing reports or test schedules, which are these huge documents that have to keep being added to more and more test cases. So at its base, what we would consider testing for this discussion is writing some code that verifies the correctness of the code in your application. So that's what a test is.
Right.
There are lots of, I'm not going to go into the distinctions of different types in here. There are many, and the balance between the different types of test is something that is a very interesting discussion and is certainly relevant to the discussion of moving quickly or slowly. There's also the separate distinction of one of the things that we like to do, for the most part, is write tests and use them to drive the design of the software. This is not necessarily a matter of correctness anymore, but it's a matter of figuring out the spec of what you're doing and being able to make a minimal change. So effectively, the things you write the test, you write the code that makes that test pass, you refactor and you move forwards. That's a slightly separate discussion. They will speak about it, and mostly, if you're in an environment that isn't conducive to it, they will be complaining that they don't feel they have time to do it. So
right.
this is a very common refrain of like, especially when I interview people and they will be thinking of an excuse why they don't write tests. It will be because, well, my manager doesn't allow it, or it wasn't accepted at the company, or these things. That is a fundamental,
which is a big red flag in and of itself, right?
It is for me. It's because it means that you don't think of yourself as a professional, because no one should be telling the developer whether they can or can't write tests for verifying their code. That's crazy. For me, testing or not testing is not where the distinction between moving quickly or not. I think I've made that mistake in the past, and it does not make you faster in anything other than an incredibly short slice of time. What might be an interesting distinction.
That's what I meant by time span. If it's very short, then yes,
incredibly short. If you're thinking in the scope of weeks, perhaps not even months, like
right
before that slowdown will happen, and you'll so you have to be adding something that's incredibly quick and it will never be touched, and just you start thinking, why are you writing it at all at that point?
Got it.
Yeah.
So just to bring it to sort of very practical terms. So Dave, you mentioned, and I think James, you were nodding when he said this. You mentioned that, look, that's how we know it's good. So you mentioned sort of there certainly is a time and a place to go really fast and write janky code, speed above all else. Give me an example of when that might make sense. Like, when does it make sense to go really fast and break things, and that's actually the right strategy to take?
Let me start by adding a bit to what James said. So it's interesting what benefits testing potentially gets you in terms of speed. And one of the benefits it gets you is that if you don't have tests, right, you can potentially have one like superstar developer that has the entire application in their head. And they are, for a certain scope of application, they are just that good that like they can add features, and because they have the entire thing in their head, they will know with a pretty high degree of accuracy what might have broken, and they can sort of do all this manually. Maybe some people might say I'm totally wrong with this. I do think there's a point, like with smaller projects, where that can work. So, but then obviously what you gain from the testing is that more than one person can work on stuff, and you can bring people on without worrying. They do not need to be complete experts in the thing to work on it without breaking it. It's a big like automatic safety net for onboarding new people. But to your point, so with those caveats, where might a case be that works? Well, here's a scenario is something like, so you have your one like amazing developer. This developer has not yet been burnt out by working in whatever environment is required them to do stuff without tests. And you've got something where you're like, okay, we've got a super critical deadline. We've got an investor who's willing to sign on, but they really just want to see an example of this one feature. And we've got like 1 month to do this. And after this is done, we can throw it all away. It's not something we're going to keep. It's not something we're going to build on. But the most important thing is that we hit the deadline. And all correctness behind the scenes. It does not matter if it's like vaporware and duct tape and chewing gum, that's all fine. In that example, I would say go for it, but also sort of to James's point, I wouldn't say go for it in the sense of like tell the developer not to write tests. I'd say developer, go for it and you write the tests that you feel will help you and don't write the ones you feel won't help you for the specific goal. Because even in that circumstance, if it were me, I would write some tests because I just know that they would pay off. But I would probably write a lot less than if I was like, I'm laying the groundwork for something that's going to last for years.
But I think the key thing there that I heard was if you're going to throw it away, like legitimately throw it away. And I think this is what we see a lot. And I think you alerted to me this first was I think a lot of founders think they're going to throw it away, but are they actually? Because they kind of, I think we've seen it quite often, haven't we? Where people have gone like, no, it's fine. We'll just go super fast, super janky. Doesn't matter. We'll rebuild it when we need to. And then they realize, oh, wait, but now we've got users. How do we throw this away? Now we have to rebuild it while we're refactoring. And that becomes excessively complicated. So just to like dive in on that point, it's like, it is cool if you're going to throw it away, if you are legit going to throw it away. Otherwise, it's probably not a good idea, right?
Yeah, I think 100%. Sorry, James, just like, yes, 100%. And I would say a good rule of thumb there is like, are you ever going to expose it to any users? Then don't do this. That's kind of why my example was it's sort of a closed demo. If you ever give it to users, you're almost certainly never, ever going to throw it away or rewrite it, even though you think you
like that. James?
I do think that the percentage of times in which you will actually write throwaway code rounds to zero. So, like,
tell me more.
It just doesn't. It won't happen once you get something going. Even if it's explicitly said at the outset of the project, this will be a thing. You will find if it's in any way useful, you will want to reuse part of it or at least some of it. So,
right.
I'm not sure that I would want to say. I would still think that in that case, still build it in a way that it could be repurposed. And I would agree with Dave there that's why I say that the distinction is not write complete trash. It's just how much, like, well, later when I know I'm going to end up reusing this because that's just what happens, I'm going to have to go back and I'm going to have to add some tests here, flesh it out a bit, maybe make this bit a bit more robust. But I'm not just going to be like, holy crap, what am I going to do with this? This is this is unsolvable.
Yeah, what I was going to say is I always think in software, it's maybe a bit abstract, but you have a very interesting, like, all of software, and I suppose it probably applies to most things you can do in reality, but it's just more stark in software because it's all kind of abstract logic. Everything you're doing is a balancing act. Like James said, there's one enormous balancing act between like basically just going complete YOLO and being completely correct. And on the one side, you have like formal verification where you need to mathematically prove that everything you're doing is correct, which you can actually only do for a relatively small set of problems. Which, as an aside, is quite interesting in the crypto space. People push quite hard on that because the cost of incorrectness is so high. But then I also think another balancing act like that when you're building something for the future that also actually kind of ties into the like going fast or slow in that is the balancing act between how specific and concrete and one purpose you make something and how abstract and general and reusable you make something. And I think that's an enormous thing that is often quite hard to see, I think, from the outside, right? So the example I think of is that if you have your computer with a programming language, right? If you have someone who's just like some kind of godlike genius, they would never ever need any other software than that because that is the most general possible tool. You would just go, here's your computing device. You can do anything you want with it because all you have to do is write the code to do that thing. And that would be a perfect level of generality for that person. On the other side, you've got completely one-purpose pieces of equipment, like, say, Bluetooth stuff. A lot of it has one button, which is pair, right? Now, you can think of like the most general case of that, where it's like, oh no, there's no buttons at all. You just have an interface to the Bluetooth chip and you can just tell it to do whatever you want. But the point is that like the general interface of the Bluetooth chip would be the most reusable. You could put it in anything if you have the skill and the time and it's worth it. And the specific thing is incredibly great at its one purpose, but it's not particularly reusable. And I think that's another big balancing act in terms of that, like, what are you really trying to engineer and for what purpose going towards the future? Because, sorry, last thing to make clear, you can waste a ton of time building more general solutions when they're not required and when a more specific solution would have worked.
It's also, I think, generally better to work from the specific to the abstract rather than trying to build abstract into like ex nihilo. So like I get your point there, yeah.
So, guys, I'm going to ask a bit of an unfair question because you can't answer this, but I'm still going to ask you to answer it to the best of your speculative ability, which is a client comes to us and says, we want you to build this. We say to them, look, our best estimate is this is going to take you 7 months of a team of X, right? So we give them a size. We give them a rough size. And that size, let's call it, is 7 months. This hasn't happened often, but it has happened once or twice over the years. That client says, no ways. There's no ways I can wait 7 months, and there's no ways I'm paying you what you want to charge. And they go away and they pay somebody, forget about paying. They go to somebody else and they get it built in 2.5 months. It's a thing. It exists. It's been built in 2.5 months. This is where the unfair question part comes in. What is that company that's built that in 2.5 months doing differently from what Nona would take 7 months to do? What's happening there that is so different? Like I say, I recognize it's impossible because you don't know the answer, but I'm asking you to speculate on what's happening there that's different. Dave, why don't you start? And James, you can jump in if you want to.
Sure. Let me address the slight ghost elephant in the room there. I think, honestly, once or twice, it is possible that we just overestimated that because we tend to be very conservative in our estimates. And so it's quite possible that something that we thought might potentially be a big deal wasn't, right? However, I will say, since we generally charge on a time and materials model in real life, that wouldn't actually have been to the client's detriment in the end. So that's one way that can certainly happen.
Just to jump in and clarify, what Dave's saying there is that we might have estimated 7 months, and that was too big an estimate. If we got the work done in 5 months, we only would have charged for 5 months. So that's what you meant by being to the client's benefit. Just wanted to clarify what that meant, because it's time and materials, not fixed cost. But anyway, as you were, Dave.
Exactly. So then the other thing I suppose I would say, what have they not done? It's a very interesting question because the world of development moves quite fast, and a lot of, I think, best practices that say some companies, and I'd like to hope we're among them, were doing that not many people were doing, say 3 years ago, have now become much more common. So I'm trying not to think historically. If I would say now, what are they not doing? They're possibly not. They're almost certainly not doing as much kind of full end-to-end testing of things, right? And I guess gets a bit technical, but there's various levels of testing you can do that necessitate various levels of manual interaction, right? I guess a good example is this, like if you're doing a mobile app. So you can have one level of test, which is just testing, let's say it's a shopping app, right? Testing the logic around your shopping cart that it gets the right total of items or some stuff, right? Which doesn't necessitate actually interacting with the app. Then you have another level of tests where it's like, okay, we know the cart works, but if I actually have the phone in my hand and I push these buttons, will this stuff actually happen? And there's many reasons that might not happen. Like maybe even though the shopping cart works, the button isn't connected to the cart, or because software is a wonderful source of constant delight, maybe there's an invisible button that sits over the other button, which means it can't be tapped, or any number of things. So if you're doing this stuff thoroughly for the future, as well as those basic tests, you would have another level of tests where you run that application in an emulator or potentially on a virtual phone or a real phone, various services, and there's various levels of how deep you go. And it simulates actual touches on the screen to test this. Now, that is, for example, a layer that you would do if you were building for the longer term. But if you were doing a shorter term project and you have a QA department, maybe you wouldn't. Maybe you just be like, okay, cool. No, we're just going to have the intern bash at this stuff every time. And maybe one or two things get through the cracks, but whatever. And that's a good example of where it's like those tests tend to take quite a lot longer to do because you're interacting with UI that can be variable and all things like this. And they will pay off on a longer time frame. Not super long, but I'd say if you're going for like a year plus, you definitely want to do this kind of stuff. But if you just want to get something out into the market, no, you can 100% save that time. So that's kind of one example.
Cool. So it's kind of like it's building with the long term in mind versus building with the short term in mind. And it kind of seems to always come back to that whole thing of like, are you going to reuse everything? Are you going to keep it? Are you going to build on it? Or are you going to have to rebuild this on the fly when you've got users, which becomes a lot more difficult?
Yeah. And
James,
one other thing there, before James jumps in, I will say, and there is also a very big gulf sometimes between like it's done and it's really done. And not always, but often in those situations, they'll be like, oh, 3 months, like it's done in 3 months. Turns out there was 3 months of like hunting down random bugs where this one person's account stopped working, or it turns out that in this particular locale with this language, the cart doesn't work, all those kind of things. So it does depend where you're drawing that line of done as well.
I think that's a big thing. Yeah, James, what do you want to add?
I'll jump onto that one and say that this is something that should make any developer shudder, is that if a client comes to you and says, it's finished, it just needs the last few bugs fixed or last things right, you should be very careful.
Run for the hills.
Well, just know that it's not going to be short. It's happened a number of times at Nona, and it's happened in other work where that last 10%, especially if it has been done rapidly and all these things, then that can be an incredibly costly thing to take it to the actual 100%.
I think I want to jump in there because it's actually something I've experienced. It's from the quote unquote business side. You guys are obviously highly technical on the building side. You're actually doing the things. I have the conversations from the other side of the table, which is just the business side of it, let's call it that, or the non-technical side. And you're 100% right, James. I mean, I've experienced that many times where people, and it's actually interesting because I've never thought of that, is it hasn't happened often, like I said at the beginning, but when we have had people not go with us and go for the really, really fast and cheap guys, that is actually what they've said when they've come back. They've gone, oh no, we got it knocked together in 3 months. It's there's 1 or 2 bugs, a couple of things we need to fix, but for the most part, it's there. And I've actually never thought to sit and ask them again in 4 months' time, hey, so is it done now? Or are you still sitting with those 1 or 2 bugs that you just needed to get fixed? It's a good point. So the definition of done is a very important part of this. Cool. So I think it's a similar sort of question, Dave, but the next thing I want to move on to is, without getting technical, if it's possible, can you answer this question to a 7-year-old type of thing, to a non-technical person like me? What are coding standards and why do they matter? So somebody's looking to contract a development house. The one house is very particular on their coding standards. They talk about them. The other development house doesn't even mention them. There is a price difference between the two. What are coding standards? Why do they matter?
Sure. I guess there's a few levels to that answer for me. Like one would be to just say, well, they're on the level of like all standards for everything, right? So having standards means that someone has considered what it actually means for a certain quality bar to be met, right? So that would kind of be a very basic first thing. But to answer it specifically, so coding standards might refer to a few different things, right? So on one level, you might have a big first step is, okay, well, there's consistency. So that means like in the actual code, things are done the same way if they're the same thing. So the way that things are named is the same. The way that logic is implemented is the same each time it's done. You might have standards around like, for example, it's not okay to manually do the same thing in different places. You have to pull this into one place. Those kind of standards, interestingly enough, they're not necessarily directly impacting the functionality of the code, but they're a lot about what is it like to work on this. So as you continue to build this, right? Here's a good example. So if we go to naming things, I always think it's maybe good to have a specific, because the stuff can sound quite abstract, right? I can just waffle about consistency and stuff. But so if we talk about naming things, you might say, okay, every time we have a function or a variable which is about the current state of something. So let's say we want to know if the user's logged in, right? There's a few different ways we could name that thing. It could be called user is logged in. It could be called logged in. It could be called online, which is sort of worse because it's more confusing because it's not really about onlineness, right? And then you might have a standard that says, aside from a general, more, I guess, it's somewhat of a subjective thing, like things should be named correctly for what they are, but you might say, whenever we're dealing with the state of a thing, it always starts with the word is. So the correct form in this case would be is logged in, is online, is error, right? That would be kind of a simple example, but it's a good one in that. So if someone else comes into that project who's not worked on it, or a developer even revisits their own code, just by understanding that internal logic of naming, as they look at it, they immediately know that any time we're looking at the state of a thing that is either true or false, it is named in that way. Otherwise, if someone were to come to it and people were naming it whatever they want, every single time, and maybe it would be called online state, or maybe it would be called not disconnected. And they'd be like, what does that mean? Right? But if you have the consistent meaning, it's instant for them to pick it up. And it's the same with sort of... Yeah, sorry?
It sounds similar to what you were speaking about earlier, which is, again, if there was one person writing the code and that person was just godlike and never, you knew that no one else was ever going to have to work on it, fine. But that's just never the case in scaling startups. So once again, it sounds like making the code as hand-overable as possible, as accessible to many people as possible, as readable by different people as possible. So like anything in life, it's kind of investing upfront early so that later on it is not as expensive and scales and grows and gets easier as you grow. Is that a fair summary?
Yeah, 100%. So like, I'll tell, since James was relating things that developers dread to hear, I'll give you another one, which is if you ever get a project that's being handed over to you and the person handing it over says, oh man, let me tell you, this whole thing was done by this one guy and he is so brilliant. He did it all himself over the course of 2 years. Honestly, that's very often quite a big red flag, because it means that project has never been like real world tested for what is it actually like if you're not the person who created it, right? So yeah, that's a massive part of standards, is like, what's it like for other people? And then another part would relate to the actual correctness and stuff. So standard might be every single thing that you do is tested. And there might be, like how we're talking about different kinds of tests, you might have standards where you say, look, all basic logic code is fully tested. All user interface code, like we were talking about, actually simulate button pushes. You might say something like, anything that could potentially have financial implications is UI tested, right? So you would have a set of rules like that. And these basically just establish baselines for where you know that the reliability will be.
Got it. So I want to start sort of beginning to wrap up the episode, guys. And I think what I want to ask both of you to answer independently, James, you can go first, and then Dave, is we started this with a kind of a question, or a question saying, should you go fast and break things and worry about it later, or should you go at a sustainable pace and build properly? What I'd like you to just summarize with just like a summary sentence is just, I know both of you, and because we work together, and I know that our choice, the way that we build things, is to go at a sustainable pace and build properly. But just summarize your reasons for why that is a better approach to building software. James, you can go first when you're ready, and then Dev.
For any time frame greater than a few weeks, I like to think of it like this, right? I don't know if any of you guys have swum before or anything like that, but there's that saying of like, slow is smooth and smooth is fast. And it is true that the same thing of like focusing on technique, focusing on getting it right, focusing on doing the correct things correct. It's not a matter of moving fast and breaking things or moving sustainably. What sustainably means is the ability to keep moving, because moving fast and breaking things means not moving fast and everything's broken on some time frame. Now, I don't know how long that is. It depends. It very much depends on the scope of the project and exactly how many corners you cut. So for me, it's just a matter of what time frame, what time slice are you looking at the problem in. So if your time horizon is anything, as most software is, realistically, there's no software that should be written without a concern for sustainability.
I love that. Slow is smooth, smooth is fast. It's what my mountain biking coach used to say to me. It's very apt for swimming as well, probably more apt for swimming. And I think that's a great summary of what we've been speaking about here. Dave, what are your sort of final summary thoughts on that?
Yeah, I don't have too much to add from what James said, actually. Like, exactly. I would just summarize it as it's not actually a choice between going fast or slow. You want to go as fast as possible, obviously, for the particular time frame you're working in. And the way to do that is to be precisely as careful and as thorough as you need to be on that time frame that will get you the most features that are working correctly. Yeah, basically like that.
Yeah, great. Love it, guys. You've given a summary, so maybe there's nothing to add here, but we've spoken about a bunch of things. We've jumped around from coding standards to testing to, I guess, an implication of investment because of timeframes. We've spoken about a bunch of things. If you haven't already said this in your summary, what is the one thing that you would want the listeners to leave with? Bear in mind that they're probably not super technical, so it's more a kind of founder type person. What's the one thing you would like them to leave the episode with? Dave first and then James.
I guess I will go based on something James said, which is that the last 10% always takes 90% of the time. And I think, I would just say that be very, very careful if you think you can avoid something which seems like it's going to take unreasonably long. Sure, there's a chance, and you should always challenge timelines and stuff you get, and any good development house will have no problem explaining to you and justifying where those timelines come from. But it's always very surprising how long it actually takes to get something 100% complete. And ideally, and we're all guilty of this, don't let your eagerness to get there allow you to engage in wishful thinking, where you just start to believe that it can be done much faster if some like pointless test that no one needs are skipped, because it is almost always going to burn you at some point.
James, what's the one thing you want listeners to take away from the discussion?
If you yourself are not technical, you need to find a technical partner that you trust when they tell you we need to move slower here, move fast. This we can skip, this we can't skip. Those are things that need to be informed by business, but are ultimately technical decisions. So don't tell your developers not to write tests, not to do things that they think they need to do for technical correctness on this thing. I get the conflict there, but I think that the key thing here is that is one of the chief jobs of the CTO, of whoever the chief technical person on the project is bridging that gap between the business impetus to move quickly and the technical side of doing things correctly. So you need to find someone that you trust when they tell you, no, we need to pay off this debt. No, we need to do this, that you are happy with that.
Yeah, I think that's very well said. I had a conversation literally today saying the same thing to not a client, just someone I was talking to, and that's not necessarily a developer. And I think that's where a lot of people go wrong. Is a lot of founders just promote a very good developer to CTO. It doesn't necessarily mean you're going to be the right CTO type person just because you're a good developer. So that's really important. And I just wanted to add, you got to trust them. They've got to be very technical. That might not be your developer. So you've got to be wary of that. Guys, thanks for making the time. As always, I've learned a bunch. I always go into these things thinking I know this stuff. And after speaking to you guys, I come out educated, which is great. So I appreciate you guys making the time. Thank you very much, James and Dave.
Cool. Thanks, Mike.
So to the listeners, I hope you got some value from today's episode with Dave and James from Nona Digital. I definitely did. I got a bunch. I think my main takeaway from today is probably just that reinforcement of, I've heard it a million times because I'm in the space, but just, the last 10% is what takes 90% of the time. I think just sort of thinking through a lot of experiences, that's just absolutely true very often. Thanks for listening to the How to Be Moderately Successful podcast. If you have a FinTech project that you would like to accelerate with a partner that will take care of your design and development to allow you to focus on your area of genius, we'd love to help you. Head over to our website, www.nona.digital, to book a call with one of our principals, or follow any of the contacts in the show notes. Last plug, we are actively hiring senior developers. We are offering a very tasty reward, so please do refer any great developers to us. They will have a good and happy home with us. I'll be back next week with another episode to help you build better businesses, better FinTech products, and a better you.